And I'll just review what we, say that one more time.
Was last class recorded?
No.
No,
Your last class was recorded at some point, but I did not record when I taught this to Alpha and A, so that's why I'm doing it now. I believe it's just called like 7-2 or something, or rest of 7-2. Yeah. Yes. Oh yeah, we did start 7.3, so it should be like a 20-minute video maybe. Beginning of 7.3. I believe I put it on. If not, I'll look at lunch. So what we did at the beginning of 7.3, and I'll just review it in case you were not here for it. What we learned at the end of 7.2 was how to do inverses. So we can do a 2x2 inverse, and we need that to do inverse method by hand. Essentially, the first thing we learned is to take a set of equations and put them into matrix form. So the first matrix we would have is A, and that's made up of all my coefficients. And so I've got the coefficients of the x's are my first column, and then the coefficient of my y's are my second column. And then I've got a variable column, which is called x, and it just goes x, y. If there's more variables, it will just keep going down that column, x, y, z, w, t, whatever. And then the last column, the last matrix is my B matrix. It's my solution. So it's just all my answers by itself on like the right-hand side in its own 2x1 matrix. In order to solve, we need to do A to the negative first times B. So if we have a 2x2 matrix, we can do that by hand. You can do inverse matrix of a 2x2 by hand, and you can multiply a 2x2 by a 2x1 and get an answer. So that's what we did here. We had to find my determinant. We had to use the determinant and flip around my matrix, and my inverse matrix for A became 1/7, 2/7, 3/7, and -1/7. And then we multiplied that by our solutions matrix. And my final answer should be a 2x1, and it should match up perfectly with x and y. So like x will equal 2 because that's the top row, and then y equals 3 because that's the bottom row. So just a review of multiplying, of inverses, etc. So we did that by hand twice. Then we did one in the calculator. So the one in the calculator we did was letter A. We had our x's were our first column, our y's were our second column, our z was our third column. And then when I write this to put in the calculator, I just physically write what I'm going to put in the calculator. I did my A matrix, I did raised to the -1, and then I did my B matrix, which came from my solutions. I had to go into my calculator and enter in a 3x3. I did the inverse of it, and then I entered in a 3x1 and then multiplied those two together. And the calculator literally gave me these answers. 3.5, -3.25, and -2.25. And remember when we went over this, the first line is what x equals, the second line is what y equals, and the third line is what z equals. Again, that seems super basic, but if you don't know that's what it means, it will make the rest of this problem super hard. Anybody have any questions yet? So that's just a review of what we did. We're going to do another one in the calculator right now. So let's go ahead and set that up. Can somebody tell me what my coefficient matrix for 2B is going to be? What's my first column going to be? First column. Good. So my first column is all my x coefficients. My second column is all my y coefficients. What's that going to be? Good. Where'd 0 come from? I don't see 0 anywhere. There's no y. I don't know who that answer. I don't answer at numbers I don't have saved. No, it's just normal call. From someone in Cicero. That can't be right. I don't know anyone in Cicero. All right, and then my third column, what's my z's going to be? Good. -1, 1, 0. Okay. So there's no y's in the second one. There's no z's in the third one. I have that shown by holding those places with zeros. Next thing I'm going to write on my paper is raised to the negative first. And then I'm going to write my solutions matrix, which is 1, 7, 6. The third column came from my z's. So -1, 1, and then there are no z's over here. So that's where there's a 0 for the last column.
And this raised to negative first, what reason?
Because we're doing our inverse method, which means that in the calculator, we're going to write a to the negative first times b. So now we're going to go enter these in for our matrices. I like to always just change A and B, but you can make like a different matrix if that makes you happy too. So I'm going to go get my calculator pulled up. If I can find it. Come on, okay, there we go. And I'm gonna go, remember, maybe it's been a couple days since you've done matrices. We do second, X to the negative first to get you to your matrix spot. Scroll over to edit. And this A matrix is a 3 by 3 matrix. So I need to make sure I'm entering it into a 3 by 3 matrix. You can always like not remember which matrix you're in. And then if you start trying to plug numbers in, you're like, I don't have enough spaces. Then you can go change your dimensions. So I'm going to do 2, -1, -1, 3, 0, 1, 2, 5, 0. Okay, I'm going to double and triple check that this is correct. I will tell you, since I've already done this twice, you will get a funky answer, but I always double and triple check just so I make sure that I know what I'm getting. And my solutions matrix, okay, mine's already in. That's good. All right, so once you have both your matrices in, we're gonna do A, raised to the negative first, times B. So I'm gonna go to my matrix menu, click on the name A so that it physically shows A on like my main calculator screen. I'm gonna raise it to the negative first. Where's that button? How do I do that? Literally the matrix button we've been pressing, I just don't press second before it. And then now I do second matrix again and I click B. So physically in my calculator, I see A raised to the negative first times B. And then I press enter. And I get all these kind of crazy decimals. I triple and double checked my work before. You may get kind of funky numbers and that's okay. I am gonna put it in fraction form, just A, to practice that skill, and B, because I think it'll be nicer answers to write. Do you know how I get this into a fraction? If you press math, and then that first one says like arrow frac, press that. And it's literally gonna take whatever my answer was above and make it into fractions. And now I know it might be kind of small, hard for you to read. It says 46 over 27, 14 over 27, and 17 over 9.
You don't want to. What you doing to get there?
Yeah, I don't mind. If I tell you directly, it must be like in a fraction, then I want this. But I just practice finding fractions just for you guys.
Okay.
Say again.
How did you get to the fraction?
You press math.
Okay.
And then the first one says arrow frac, enter, and then enter again. So I got 46 over 27. I got 14 over 27, and I got 9 or 17 over 9.
How did you get the end of G rhymes?
I did my second matrix, excuse me, and my like A was just already by itself, ready to go.
So then when you multiply them in the calculator, how did you do that again? Like how did you get the negative 1A?
So I went to matrix and I had already adjusted matrix A. So I knew matrix A was what I wanted. So I just press enter. And then -1 is the button we kept pressing for matrix, but just don't press second before it. Just press X to the negative first. And then I'll do second matrix again to get matrix B up there. And then I press B. And then I press enter. Mm-hmm. And unless I ask for an exact, or if I say like specifically use fractions, you can leave it as a decimal. I just like, I don't know how many places to round it to. It's just kind of messy. So I thought fraction was better, but either way is fine. Okay.
Why isn't like the bottom ones like over 27?
Because it was simplified down. So like that's telling me that like if this was over 27, it would have been like multiplied by 3 on top and bottom. So it just could simplify down one more than the other ones could. All right, what other questions do we have? Anything right now? Okay, we're gonna skip Kramer's rule for right now. We're gonna come back to it probably after lunch. I wanna do a little bit more calculator stuff while we've got the calculator in our hands, okay? The next 4 problems, the rest of this section is talking about something called Gauss-Jordan reduction. Gauss-Jordan reduction. What that means is we're gonna get our matrices in a specific form, and we can do this by hand, but I'm not gonna make you do this by hand. So if you were to go to college and take a specific class on matrix algebra, you would do this by hand. We are not learning it by hand. right now this year. So what we're gonna do is we're gonna put it in the calculator, but we have to put it in the calculator a specific way. We're gonna do something called an augmented matrix. Instead of having a 3x3 and then its solution a little 3x1, we're gonna like kind of mash those two matrices together, and we are going to, instead of having a 3x3 and a 3x1, we are going to make it a 3x4 matrix. So we're essentially making those two matrix into one matrix. And when we write it, we don't have a separate bracket in between those two. I just put like a big line down the middle that shows me this is my coefficient side and this is my answer side. We're going to set up our matrix the exact same way we did before, but we're just putting it again into one matrix instead of two. So like my first column is going to be my x's, my coefficient of my x's. So 1, 2, 3. My second column is going to be my coefficient of my y's, 1, -1, 1. And then the last one's -1, 3, 1. Very good. And then the very last one is my solutions matrix. So I'm going to make that 2, 14, 14. Okay, anybody questions yet? This is what we call an augmented matrix. An augmented matrix will never be square. It will always have one more column than it has rows because I'm including the answers in this problem. Okay, let's go enter this in the calculator, and then I'm going to tell you what button we're going to press to get our answer out. So I'm going to go to my, not that. I'm going to go to my matrix button. I'm going to go make matrix A not be a 3x3. I'm going to make it a 3x4. We're going to enter this matrix in. 1, 1, -1, 2, 2, -1, 3, 14, 3, 1, 1, 14. Okay, once you have your matrix, double check it, triple check it, quadruple check it. Now, I'm going to go press this button in the calculator. I don't have it on mine, so if you're using my app like me, you're just going to have to watch and we'll get the answer from everybody else. We're going to press the button REF. Now, you don't have to write this down. You can just listen to me. REF stands for row echelon form. Wow, if I could spell a little bit better, that'd be great. Row echelon form. REF, row echelon form. That's going to be a specific way that the matrix knows to organize itself. So I'm going to click out of my matrix and I'm going to go back to my matrix menu. And remember, for determinant, we hit the math button. I'm going to scroll over to math, and I want you to scroll down until you get to letter A. Now, I don't have letter A. I have 0 and I have letter B. Your letter A should say REF. Nod to me if you see that. Okay, good.
Oh, wait, never mind. Wait,
Go all the way down to A. Are you on? You're not on the right math. Go to matrix and then go to math. Good question. We can't just use the general math button. We got to press matrix and then we press math. Good. I'm going to press RREF because I'm going to show you something in a second. But you're going to press the one that says REF. You're going to press A, REF. And then you're going to do it to the matrix that we wrote in our calculator. So I'm doing matrix A because that's where I put my matrix.
Click the one with just one R.
Just one R. You click the one with just one R. The 2 R's is a shortcut, and I'm going to show you that in a second, but I like to do the harder one and then the easier one.
Can you repeat this one more time while I get to the
Go to matrix, second matrix, and then scroll over to the math like menu. And then scroll all the way down to letter A. And then press enter.
Mine's still not there. This says log
And then in your calculator on the screen, it should say REF and then A, and then you should be able to enter. And this is what you should get. Did you figure it out? I think it goes 1/1/3. What? Oh no, sorry. Yours is in decimals, right? Can you make it into fractions? Remember how to do fractions?
Can we do this decimal?
I'd rather you put it in as fractions. It'll make more sense. We got an error. Did you use the right matrix?
Use that one.
Oh, you need to do REF and then you need to press A. Good question. Math. Press math and then press the first one says arrow fraction. Press enter and then press enter again. It should be 1/1/3, 1/3, and then 14/3. Is that what your thing's starting to look like?
14/3.
Might have to scroll over. And then you should get 0/1. Is it -7/5? Okay. And then +14/5 or -14/5? Negative. And then you get 0, 0, 1, and then you get 2. Again, if you're using the calculator like me, we don't have that on ours. But if you have yours, does anyone need help making sure that they got this answer right? Okay. What this means is that everything in the first column is a coefficient for an x. Everything in the second column is a coefficient for a y, and everything in the third column is a coefficient for a z. You don't physically have that line on your calculator, right? But every time we do an augmented matrix, I'm going to put that line because that tells me that those things equal, and then this last column is my solutions. So what this tells me is that if I'm reading the first line, if I'm reading this first line, 1/1/3, 1/3, 14/3, that's the same thing as 1x plus 1/3 y plus 1/3 z equals 14/3. Are you okay with that? So we're just taking the top row right now. That top row by itself is an equation that equals x plus 1/3 y plus 1/3 z equals 14/3. Are you okay with that? Sure. We're going out of matrix form into equation form. So we did earlier into equation form into equation form from matrix, and vice versa now. Now let's look at the second row. The second row would be 0 x's. Do I need to write 0x down? No. So then I've got 1y plus -7/5, or you can just write -7/5 z equals -14/5. Okay, with the second row? And so what does that mean the third row equals? Z equals 2. Oh, that last one's a nice one, isn't it? Super nice. That just tells us Z equals 2. Now, based on the equations that we have, we are going to use the fact that Z equals 2 to find Y and then use that new Y to find X. I'm going to plug 2 in for Z into the equation above us, and then I can easily find Y, right? If I substitute in 2 for Z, then I just have one variable. I'll come over here and do it over here. So instead of doing y minus 7/5 z equals -14/5, I'm going to plug a 2 in for that z. So I'm substituting in. I got z equals 2, and I'm going to substitute that 2 in. All right, -7/5 times 2 is going to be -14/5. If I add those 14/5 to both sides, y equals 0. Hey, it was really ugly, but now that's a nice answer, right? Y equals 0. I'm cool with that. Are you cool with that? We're just substituting. That's like an algebra skill. Substituting in y equals 0.
That's the final answer.
That's my final answer for y. I got one more thing to find. I got to find x too. So I knew y or z equals 2, and now I know y equals 0. And now I need to find x. I'm going to plug 2 in for my z, and I'm going to plug 0 in for my y. Everyone okay on that substitution? Okay, let's do it. So I've got x plus 1/3 times 0 plus 1/3 times 2 equals 14/3. What's 1/3 times 0? 0. What's 1/3 times 2? 2/3. So I've got x plus 2/3 equals 14/3. And then minus those 2/3 from both sides. 14/3 minus 2/3 is 12/3, which is just 4. Look how nice that was. Okay. I'll get rid of the calculator for a second. So that was what we call row echelon form. Row echelon form means that my diagonal is going to be made up of only ones, and everything below the diagonal is 0. I can have numbers in every other space, but what we are doing is we are essentially simplifying the systems of equations down so that I've got ones all along the diagonals and I've got zeros below it. Okay, if I just click on row echelon form, I'm going to get a series of systems of equations, and it will be easy to solve them, but I essentially am just going to substitute kind of my way up the little ladder to get what x and y are. Okay, now I did not get to press that button because I didn't have that button. I want us to all go press REF now. REF, if REF was row echelon form, REF is reduced row echelon form. And we're going to see what that means in a second. So you don't even have to change anything in your calculator. We are just going to use that same matrix A, but I want you to press REF before you press matrix A this time. So again, go back to second matrix, scroll over to math, and this time we're going to letter B. B as in boy, which says REF. It has both of the R's. Okay. When I press that and press my matrix, I'm going to press enter. Ooh, look at that pretty little matrix I get. This one says 1 0 0 4 0 1 0 0 and then 0 0 1 2. If I use the same concept I did for the last one to write equations, what would my equation for my first line be? Yeah. Is that what I got x to equal earlier? Cool. What would my second equation be? Good. Is that what I got y to be earlier? Yep. And then what does the last equation mean? Z equals 2. Oh, they gave us that before. So reduced row echelon form means that not only do I have ones across my diagonals, but I should have zeros everywhere else, above, below, in between, left, and right. And then the reason I like this one the best, or that you guys will like this one the best, is it just gives me my solutions right here.
So we don't have enough.
You don't have to do any solving or substitution because you would have already been there.
Okay, so we didn't have to do any of that. That's just to show us that we can do it by hand.
I could ask you to do RR or REF. I could ask you to just do this form and then show all the substitutions, but you would have your calculator. Could you check to see what the answer should be? Yes. So I would want all this work, but you would be able to show me the other stuff. When we come back from lunch, we're going to do B and C and D all in RREF, and then we'll learn Kramer's rule, okay? I will see you after lunch.